It's Marty, and good morning. It is currently 7-something a.m. And welcome to part 22. Is it 22? Yeah, it is. Welcome to part 22 of the C++ and SFML 2-buffer tutorial series. Today we're going to be doing something a little bit different. We're going to be setting up SFML to run on Linux with C++. Now, if you're just a Windows user, feel free to stick around to the end of the video too. I mean, you might learn something new about Linux, but of course I don't expect you to. Before we get started though, since it is kind of early in the morning, I have heard that drinking coffee in the morning helps programmers wake up. So, since my dad already brewed a batch, I figured might as well try it. Blech, nasty stuff. Alright, so you can see I've booted over to Linux Mint 18.2, and I'm using Cinnamon as my desktop environment. So let's start by going over to the terminal. Now, my Linux might not look the same as your Linux because I've customized this Linux to exactly how I like it. Because if you're on Linux, Linux equals customization. It's so customizable, why not? So then go underneath administration, and you're going to want to go with terminal. Programming tip of the day, hardcore Linuxers, use the terminal. Let's start by typing ls to tell us exactly what we have on the screen. It's ls, not, oh, I see what I did. I typed out sl. Although sl is a pretty cool command, it's not getting us done what we need to get done. Okay, so we're going to go ls, not sl, and that's going to tell us what subdirectories we can browse into. So let's browse into the desktop. I'm going to be doing all this development setting up on the desktop just to keep things simple. So cd desktop, if you already started to type out the name, you can use tab to autocomplete, hit enter. So now if you type ls again, you should see a whole ton of stuff. We're going to make a directory called dev because this is where we're going to do all development. You can name it whatever you want, but it's pretty common to just name it dev. And you don't want to go cd because that's browsing into a directory. You want to go mkdir, which is to actually make a directory, dev. You could use it using your graphical user interface, but it's way cooler doing it this way. Now we can actually browse into the dev directory, so cd dev. Now, if you type ls, we should have absolutely nothing in here. Gotta go mkdir to make a directory. Now, if you want to make a directory that has spaces in its name, you have to use quotes. So that's going to be, we're going to call this a 2D platformer because it is a 2D platformer. Now, if you type ls, we should see we have a subfolder called a 2D platformer. Now, to browse into a folder that has a space in its name, you're going to have to use quotes again. So if you just type 2, use tab to autocomplete, it's going to know we're talking about 2D platformer. Hit enter. Now we should see absolutely nothing in here. Now we're going to need to make some more directories with mkdir. We're going to need a directory to store all of our C++ source files. We're also going to need a directory to store all of our header files. So I like to name it include. It's fairly specific. Include is going to be where our header files. If you don't know what header files are, don't worry about it. We're going to explain it more as we carry on. We're going to need a bin folder to contain our outputted application or our binary. We're also going to need a folder called assets. This is where you'd store stuff like images, font files, all that. And we're also going to need one more called data. This is where we would store something like a player save function. Hit enter and it should make all of those directories. Hit ls. We should see we have assets, bin, data, include, and source. Perfect. That's about all we're going to need for now. Just clear the screen with clear. Now we're going to need to actually start installing some stuff. Let's start with updating our repository. So sudo apt-get update just to make sure our packages are up to date. So give it your sudo password. Feeling confident. What? My brother always tells me that my password is way too long. I personally think I enjoy long passwords because of the trauma Windows 10 gave me. Sometimes I still get night frights about getting hacked by Windows 10. Because we can't just write C++ code into a text file and expect the computer to know what we're talking about, we need something to compile our semi-machine, semi-human code into machine code, which is a binary ones and zeros. To do that, we're going to need a compiler. Luckily for us, we don't have to make our own compiler. G++ is already out there, completely free compiler out there. So we're going to go sudo apt, make sure you're using sudo privileges, apt-get install G++, and you don't need to specify which version is. We're going to go roll with the latest version and it should install it. Alright, so we've got our compiler installed. Let's just clear the screen a second to make it look nice. Now we're actually going to need to install the SFML library. Now this here is probably the easiest way of doing it. If you just install it to the standard path, it's going to take care of a whole ton of headaches, so you don't have to actually find it. So if you go sudo apt-get install and then lib sfml -dev. That's, make sure you do have the -dev there. Hit enter, it should install. Quick second. There we go. You can see that we've installed 3.2.2. You You could probably add a flag to that if you wanted to go with 2.4.2, but for this tutorial, it doesn't really matter. We can just roll with 2.3.2. Let's just clear the screen again. Alright, so we've got our tools all set up here, but we're missing one, and that's just a simple text editor. There's a variety of different text editors you can use. Some people enjoy using Vim. I enjoy using Vim occasionally, but then I feel like ripping my hair out, and then I go back to Sublime Text. There's nothing on Sublime that you're not going to get on any other text editor. It's just a really nice text editor. Whoops, I just realized I was using my ugly chore sweater to do this video. Man, that sweater has been through everything. It's been bleached countless times by the sun. It has paint all over it. Oh well, might as well just roll with it now. I mean, as they say on Broadway, the show must go on. Okay, so like I was saying, let's install Sublime Text. First, we're going to need to add a repository. If you don't want to type out the whole thing, it's down in the description too. You can just copy and paste it from there. Hit enter from there. Of course, if you want to roll a Sublime Text 3, you could change that 2 to a 3. Hit enter to continue, but for this tutorial, Sublime 2 is just going to do just fine for our purposes. Okay, now we can actually install Sublime Text. So go sudo apt-get install Sublime. Make sure you have a dash text. The dash is important. Alright, let's clean up our terminal with clear to just clear the screen. And now we can actually run Sublime. So go sub and then L, hit enter, and we're going to open up Sublime Text. This is what it should look like by default, but I noticed a few problems here. It tells me we need green. Dude, that font's kind of small. Let's start by installing the package control. So go Control Shift P, scroll down until you see Install Package Control. Click on it and it's going to install Package Control. Package Control is just an installer for a whole ton of packages that comes with Sublime Text. Go Control Shift P once more. Now we can actually use Package Control to install a package. So click on that again. We're going to type color because we're looking for a color scheme. Color, and I like to use the vintage terminal color scheme. I mean, there's tons of great stuff there. It's going to install a second. That's actually a pretty nice little effect to show it's installing. And when it's finished, it probably won't say anything. Then just click Preferences, Theme, or actually Color Scheme first. Scroll down. I like to use the green, not orange, the green color scheme. There's actually tons of different color schemes, but this screams awesome. I mean, look at that. It's like so matrixy, it's so programmer-ish. This is my personal favorite setup. This doesn't seem to go with a nice dark green theme. So go Preferences, Theme. Let's go with an adaptive theme. Much better. It really contrasts nicely with this green theme. And that font's probably a little hard to see. If you're holding Control and then scroll, you can make the font bigger or smaller, depending on how you like it. There we go. That's readable. Alright, so you can take that all. We're actually ready to start coding. Almost. We actually need to create a build script that's going to call our compiler and then pass some flags to it, and it's going to have to handle all the linking as well. How does the linking work, you might ask? I mean, it would probably be better if I pulled up a visual demonstration because it's pretty complicated. Okay, in case you couldn't tell, that's SFML. That's just with really bad handwriting, because trying to use the mouse to handwrite is pretty sucky. This here is our code. So the compiler needs a way to actually say SFML find our code. And basically what the linker does is the linker copies the contents of SFML and pastes them right in there with our code. That's all it literally does. You might be saying to yourself, well, if that's all it does, why do we have our classes split up into different functions? Why would there ever be a need to do that? The reason for that is if you had a billion line of code is pretty long. It would take forever to scroll through and find what you're looking for. It would be way simpler to split up a function. For example, if you perfected a collide function, it'd be simpler to just save it in a different file and not ever have to worry about it again. So the linker just links it over so I can find each other, copy and paste SFML into our code, so it's going to work all nice and fine. We're going to be using a bash script to do it. So let's start the bash script how any bash script starts, with hashtag / bin and / bash. Now this here is actually going to do literally nothing because it's just a comment, so don't worry about it. Let's create a variable. We're going to call this here app running. This is just going to tell us if the app's running. Set it equal to 1. Now you might be taking notice that I haven't used a nice little space like I typically like to. That's because you can't. Bash is so picky about their syntax. I mean, you miss one space and you're done. Hit enter, and we're going to create a while loop. This while loop is going to run infinitively because we want it to. Open up some square braces. To access the app running variable, go with $, and then app running. Make sure you have a space after app running. Is equal to 1. Be sure you have another space after 1. If you don't, the compiler is going to freak out on you. Now go semicolon do. So we're saying, okay, while the app is running, you're going to do this. We can start by printing out a nice message to the screen. Be sure you've tabbed over correctly, of course. So we're going to echo compile and run just to tell the user which commands do what. So compile run, we're going to use 1 to just compile for debugging purposes. We can use 2 and to just exit. I mean, we could go with that exit button, but we want this to be cool. We're gonna have to have another function for that. Okay, this alone is actually going to do literally nothing besides print some text to the screen. We're actually going to have to gather some user input. So go read user. This is just to tell bash you're expecting some input from the user. Read, and user is just the variable name. It's going to say, okay, some keys are going to be pressed. Assign those keys to user. Assign those values to the variable user. Let's create some if statements. If open up 2 square braces. Be sure it is 2. I don't know why they have 2, but be sure it's 2. Space. The space is important as well, because like I said, bash will freak out on you if you have 1 space out of place. If user is equal to 1, be sure keep in mind that space. It's kind of ridiculous in my mind. I mean, literally 1 space. Is that going to hurt anyone? I guess bash thinks so. Then we're going to want to do something. What are we going to want to do? We can echo a nice little command. So we're going to print something out on the screen, compiling, to make it look like we're actually doing some work. Compiling and then running. Let's create an else if statement. So elif is how you do it. Space, open up some square braces. Inside the square braces, open up some more square braces. Spacing is important, as you've probably learned by now. User is equal to 2 semicolon. Then we're going to echo out something else. So echo, and then we're just going to go with just compiling. Now we don't want to use an else here because, I mean, what if he has a slight little typo? We don't want to exit him out. So we're going to go with an elif to make sure he's not pressing any of the other keys. Space, open up some square braces. Inside the square braces, open up some more. And then if the $user is equal to 3, make sure you're tabbed and spaced out appropriately. Semicolon, then we're going to just exit with just exit. After that, detab and type fi to say that we're finished our if statements. And then outside here, make sure you're completely detabbed. Type done to say we would be done the while loop. Now we actually need to save it. So Control Shift S to actually save it as something. Save it to the desktop in our development folder in 2D Platformer. Right here, you can name it whatever you want. I'm going to go with build because it makes sense. It's a build file. It's going to be building all of our code. You can name it whatever you want, but the important thing is .sh to say it's a bash script. Hit save. Alright, now head over to the terminal again. Type ls to see what we have here. Okay, you can see we've got a nice little build.sh here. Before we can actually run it, we have to mark it as an executable. To do that, go chmod plus x. Make sure it's plus x, not minus x. And then the name of your build script or your bash script, build.sh. Hit enter. If you typed it all out right, there should be no errors. Now I can actually run it with ./build.sh. Hit enter. Okay, so compile and run. If we hit 1, it's going to say compiling, then running. Perfect. If we just want to compile it with 2, it's going to tell us we're compiling. Other than printing out something to the screen, it's doing actually nothing. So, wait, don't close the terminal. Cancel. We can exit with 3. There we go. Perfect. At this point, no errors. Now, let's actually get G++, our compiler, doing something. Let's go G++-C. What are we going to want to compile? We're going to want to compile everything inside, all of our source files inside the source folder. So to do that, go source / and then asterisk to say that everything that ends in .cpp is going to get compiled. Now we can actually add a couple flags here. This here, the std one, is just going to say which version of std we're going to be using. We can roll with 14. It's going to work fine for our C++ needs. You could use 11. It really doesn't matter for this tutorial. Space, and let's add one more. This here is just going to say w_array. It just says print all your arrays to the screen. Now this is probably the easiest way of doing it. So this here is just going to make these some O files, which are just some output files. After that, it's going to get linked and then finally get compiled to binary, aka an executable on Windows. So to do that, we're going to need to stitch together all of our O files into one big executable or application, whichever one you want to call it. So we're going to want to use the asterisk again to say everything that ends in .o is going to get linked and then compiled. Add the flag -o to say where we want to output this to. We're going to output this to our bin folder, and you can name it whatever you want here. Just make sure if you name it here, just keep in mind what you named it. So ours is going to be game because it is a game. Now here's where you actually link SFML over to our project. Now like I said before, when I said this is probably the easiest way of doing it, the way we did it now by installing it to a standard path, it's going to be able to find it no problem. So we can just go -l SFML and then whoops dash graphics. There's actually a whoops key, I was just saying whoops. The L stands for we're linking over these libraries, and we're also going to need what is window, and we're also going to need one more. These here are the mandatory ones that you're going to need. SFML and what's the last one? System. That's right. System. They do actually have to be in that order. Stick to that order. Don't change it up too much really there. These two here are completely optional. So that's L SFML dash audio. So now this is for actually playing audio files. If you don't have any audio in your game, you can just leave that flag out. If you do, I'd recommend putting it in anyway, because we're probably, by the time the series is done, we're going to need some audio. Add a dash as well. L SFML. The last one, this one is called network. Now, why would we need this in a C++ program? To answer that, for example, if we had a multiplayer game and we wanted to play over the internet, we would need a networking function. So that alone is going to compile it. To actually run it, go ./bin, because it's located inside bin, /game. Now that's actually going to run it. So now we can copy these two lines of code here, Control C, and paste them into just compile. Now you might be saying, okay, Marty, this doesn't make much sense. Why would we need to have a separate function to compile and a separate function to just compile and run? Good question. The reason that is because if just debugging, you don't want the little game popping up in your face, because even if this here does not go through all well, the game's still going to get ran anyway. With compiling, it's just going to compile, tell you your error messages, and leave you with that. And that should do it. So go Control, save, and if you run it again, this time over in our terminal, and look at this, 2 programming tips in one day. You can use the up key to reference the last command you typed. Okay, so let's compile and run it with 1, and we've got ourselves some awesome errors here. G++ error, there are no CBP files. That's right, there are no CBP files. So we can go with 3 and exit. If we just compile, it's going to say the same thing anyway. So now I actually have to make some CBP files. So let's go over to our Sublime again, Control in to create a new file. And now here's where we can open up the code we've been working on the past 20 tutorials or so on Windows. So you can just open up that main.cbp, open with Sublime text. If you haven't been following the series, don't worry, I'm just going to scroll through a quick second here so you can make sure you're all caught up, in case this is where you just jumped on because you're using Linux. So I'm just going to scroll through it a quick second. I wonder how many lines of code we got here. Okay, 166 or 167. So just copy all that. A little shortcut is Control A it took roughly the same amount of time. So Control C, paste it over onto Untitled. Now Control Shift S to save it as something. We're going to save it into Marty, or actually desktop, dev to the platformer source. And we're going to name this main.cbp. You can name it whatever you want, but it's a good idea to make your main file main.cbp. It's just good programming practice. Save. Before we can actually compile and run it, we're also going to need one more thing from here. We're going to need to copy the assets and the bin folder to copy over our images and fonts. If you're wondering what I have inside assets and images, I just have all these. Now I can go to select more than one folder at a time, just holding Control, click on the 2 folders, Control C, because we don't want to move them. We want to copy them over into dev, to the platformer. We can paste them in there. It's going to ask you if you want to merge them. Yep, apply it to everything, merge it, no problemo. Now we are actually, or should be actually, ready to run our build script. You don't actually have to use the terminal to run it. You can just double click on build.sh and click run in terminal. Okay, let's just compile it. Let's just see if we get any errors. Compiling, no errors whatsoever. Perfect. Let's compile and run it with 1. See if it compiles and runs, goes through all good. Right there. On line 13, take out that B and replace it with an N. Control save, and now we should be good this time, hopefully. I can close out of that now. We should be good to actually double click on it, run in terminal, and 1 to compile and run it. Alright, so we have it compiled to what we are actually at on Windows. Perfect. But there's one more thing that we're missing here. Do we want this to be filled up? Like if we repetitively compiled it and just kept repetitively compiling it, our terminal's going to get pretty full. We're going to want to clear the screen, but we're only going to want... Why is there a .o? What do we name our source thing? Oh, it's main.cbp. Okay, rename that. We don't want to go .cbp, just main.cbp. Now delete that main.o. There's no reason to have a ... It's just 1. Now let's go back into our Sublime, and here we're going to add a little bit more here. So now we're actually going to read some user input. So read -in is to say how much user input. Just one key of any kind is going to work. And then -s to be silent, so it's not going to print anything. Then, whoops, what did it do? Oh, auto-completed for me. Okay, then we're going to clear the screen. You can copy those 2 lines of code, Control C, copy them down below. So what it's going to do is it's going to compile it, check for error messages. If there are error messages, display them to the screen. Let you press enter once you want to repeat the iteration. This way we can read our error messages, and then it's going to close the screen after we're done reading them. So we can just close out of that because we're going to have to reload it because we renamed it. So close without saving, all good. And now I'll go back to the platformer, double click on build.sh. Hopefully this should run all good. So 2 to compile it, compiling. And now it's just waiting for user input. Hit enter, clear the screen, perfect. Let's compile and run it. Compiling and then running. Perfect. Now if we hit enter, it's going to erase everything, go back to the main iteration. So that is actually it. We are completely set up on Linux for C++ and SFML. And now as the game gets more advanced, you're going to see why we have an include folder. We're going to get more on header files later. So if you're actually a Windows user, and if you surprisingly stuck around to the end of this tutorial, I mean, I didn't expect that you would, but if you actually did make it, you might be saying to yourself, wow, this is really cool. Can we do the same thing on Windows? And yes, we can. In the next video, we're going to be setting up SFML on Windows without the IDE. So we're going to ditch that IDE, and we're going to go with some text editor and the terminal, or the command prompt as it's known as on Windows. Some programmers look on using a text editor and then the terminal to compile barbaric coding practice. But in my opinion, whatever you like, go with that. If you like using an IDE, of course, go with it. But everything an IDE can do, you can do with terminal or command prompt if you're on Windows. This is 100% preference. You don't have to do it this way. This is just my preference right here. Alrighty, so I hope you guys all enjoyed this video. If you have any questions or comments about using SFML on Linux, just leave it down below in the comment section. And thank you for watching and subscribing. Every single subscriber does help us out. So I'll be seeing you next Monday. Marty out.